Good day to you. This is teacher Leland, Alejandro, and we're going to discuss isosceles triangles in geometry. We're going to have the problem set on the other screen, and we will be solving unknown sides and angles in a given figure involving isosceles triangles. All right, so let us see the problem set first. Okay, here's the isosceles triangle worksheet, and we're going to see how many problems we have for this. This is about, is it 20? It's about 18 numbers, okay, with figures. So let us see the first problem, and we're going to solve it presentation view. All right, here's the first diagram. Okay, find the value of x. Okay, the x here is side, okay, so we can see the diagram. It involves a triangle, and the triangle has one given side and two angles that are given congruent. They're equal. So if two angles, so we have some definition and theorems about isosceles triangles. Okay, and it goes like this. If two sides or two angles of a triangle are congruent, then okay, if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Okay, there. So we can actually make use of this. All right, so if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. And so by this statement, the value of x here is also 14. Okay, so that's the answer. X is equal to 14. So we have side x is equal to 14 units there. Okay, that should be the answer, and we can always verify that. Okay, there. All right, the answer there is 14. All right, and so let's continue with the next figure. This is rather easy. Next, let's continue with the second number. All right, here's number 2. Okay, find the value of x. Here's another triangle, okay, with two markings inside, markings of the angles, and those markings tells us that those two angles are congruent. Okay, now these two angles have opposite sides, the x and the number 10, okay, or the 10 units. So by means of the theorem, okay, if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Okay. All right. And so we have the value of x here. Without any computation, we can conclude the x is also equal to 10 units. Okay. Equal to 10 units. So the side x is equal to 10 units. There. That should be the answer. All right. And so we can verify that. Okay. It's 10. The answer is 10. All right, that goes to our second problem. All right, let's continue with the next. Okay, these are rather easy questions. We can check on number 3. All right, here's the figure. Let's shrink it a little bit. Find the value of x. Okay, the x here indicates a side. Okay, representation for the measure of the side. Now we have the markings of the angles that you can see in the figure. We have all the three angles. Okay, they're all marked with a red marking. Okay, so those supposed to be equal angles. Now, when these angles are congruent, then all the sides are also congruent. And this is supposed to be equiangular, okay? Equiangular. So for equiangular triangles, it is also equilateral, okay? And so the value of that unknown side x is also 7, okay? So the value of the answer here, okay, side x is also equal to 7 units. There, that's the answer, okay? And we can verify that. That must be also 7, okay? There. All right, you can see the blinking number 7 at the bottom of the drawing. All right, and so we're done with this. We shall continue with the next number 4. Okay, here's number 4. Okay, a similar simple figure, okay, with two angles marked congruent, okay? When you see those marks there, that means those angles are equal. And we can make use of the statement, if two angles of a triangle are congruent, then the sides opposite those angles are also congruent, okay? The sides are congruent. And the converse of that is also true, okay? If two sides of a triangle measures the same or congruent, then the angles opposite those sides are also equal in measure or congruent. Okay, that's the converse of the statement we have on the screen. Okay, so for this particular number, the value of x here is also 12. Okay, so this will be side x is equal to 12 units. There. Okay, that's it. And we shall verify from the computer's database. The answer is 12. Okay, very easy. All right, let's continue with number 5. Here's number 5. Okay, we have here, all right, all three of the angles in the triangle are equal in measure, okay, because of the red marks. And so we can definitely conclude the value of all the sides are equal. And the x there measures 9 units, okay? The measure of the side, okay? Side x is equal to 9 units. There, okay? That's the answer. And we can verify that. There, okay? You can see the number 9 at the bottom of the figure. That indicates the answer. All right, and so we can continue with the next number. Let's proceed to number 6. All right, here's another figure. Okay, another figure of, well, slightly different diagram, but you can see the marks of the angles are there. Okay, this means the two angles of the triangle are congruent, and we can make use of the same statement. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. And so we can conclude the value of x, or side x, is equal to 13 units. There. So side x is equal to 13 units. All right, and that's it. Let's continue with the next. Let's continue with the next, and that's the answer, 13. Okay. All right, and we can continue with number 7. Okay, for number 7, the x is no longer a side, okay? And we're asked to find the x, but this time the x is unknown angle, okay? Unknown angle. All right, and so we can solve for the unknown angle by means of the definition of isosceles triangle. Now, for isosceles triangle, we have some descriptions about isosceles triangle, okay? Consider this drawing, okay? And say, for example, this side is equal to this side, okay? Then the angles here called base angles, the base angles are equal, okay? So this is the definition of isosceles triangle, okay? So the two sides of an isosceles triangle are congruent. That means equal in measure, okay? The two sides of an isosceles triangle are congruent, okay? And the angles, the base angles, okay? And the base angles that are opposite the two congruent sides are also congruent. There, okay? The two sides of an isosceles triangle are congruent, and the base angles that are opposite the two congruent sides are also congruent. So these angles are equal, okay? This is equal to this. And this angle here, the third, okay, this is called the apex angle, okay? There. All right. So we're just trying to discuss the names, and yes, so the two angles that are congruent are called base angles. The one remaining is called the apex angle. All right. Let's continue with the problem. All right. Let me clear my definitions here. Okay. Let me. All right. Okay. What we have here in the diagram, we have two sides with marks. That means those two sides are equal, and the 92 degrees is the apex angle, okay? And we can actually subtract that value from 180, okay? Subtract that value from 180, and the result will be the sum of the remaining two equal angles, okay? The sum will be the the sum of those two will be the result of subtracting 92 from 180. Okay, so what we will be doing first for the solution, okay, all right, let us solve. Okay, here's the given apex angle is equal to 92 degrees. There, okay. Now we're going to subtract 92 from 180. Okay, so we're going to do subtraction. So 180 minus 92. There, okay. And so we're going to have the result that should be about that's 80, 88, something like that. So this will now be 8, and then that becomes 17 minus 9. So this will actually become 88. All right. So this will be the result of subtraction. Okay. So this 88 degrees, okay, because the measure of this is in degrees, we will have to divide this by 2. Okay, this 88 degrees will be divided by 2. So if we divide 88 by 2, we get a 44. Okay, so that's the way to do it. So you have here 88, and you're going to divide it by 2. There. Okay, 88 divided by 2 is 44. Okay, so we're going to get a 44 over here. There, okay? So the answer here is 44 degrees. So to give a little check, okay, the sum of all the angles in a right triangle, okay, we can do a check here so that we can have 44 degrees plus another 44 and the given 92. All right, so we will have to get the sum, okay, and what do we get here? This will be 10 carry over of 1, okay, that will be 5 and 4 9, 9 and 9 is 18, so this will be 8 8 and a 1 there, and so this will be 180. All right, this will be 180 degrees. Yes, that should be 180 degrees. Getting the sum of this, that will be 180 there, okay? If you get the total of this, that will be 180 degrees. All right, and so 44 degrees will be the value of x, okay? And this means you have a value 44 from the drawing. This must be 44 here. That's a 44 degrees there. Also, the x here is 44, okay? So this x here, this is 44 degrees. Like that, okay? All right, so it's 44 degrees and 44 degrees and 92. So the answer here must be 40, 44 there, okay? All right, and so you can see it as indicated by the computer. It's 44 degrees, all right? Okay, that goes to our number 7. We're looking for the angles this time, okay? The first 6 numbers we were looking for, we were finding the sides, okay? So x can be a side or angle, okay? All right, let's continue with number 8. Let's continue with number 8. Let me clear. Let's have number 8. Okay, here's next diagram. Find the value of x. All right, the x there looks like an angle, okay? So just to clarify, this x is like that, okay? There, it's an angle, all right? That must be an angle, okay? All right, how do we solve this? We're going to consider a linear pair, okay? Consider this angle 147 plus this angle, all right, plus this angle. This must be 180, okay, 180. So let us call the angle inside, let's call this first y, okay? Let's call this y. And then from there, we'll be able to conclude that that y is also a y here, like that, okay? All right, that is angle y. The other is also angle y because of the marks. You can see the marks here, this mark and the other mark, okay? And if two sides of a triangle are equal, the opposite base angles are also equal. The angle y and the other angle y are equal, okay? Those are the base angles. All right, now we are actually solving for the apex, okay? We are solving for the apex. All right, so this is going to be a step by step, okay? So from 180, so let us start our solution from the given angle. Given angle equals 147 there, okay? That's the given angle. So by subtraction and by the principle of linear pair, we have our first equation, which is y plus 147 is equal to 180, okay? And y is equal to 180 minus 147. Okay, and we have angle y. All right, that should be about 33. Okay, 33. Yes. All right. So we're going to make use of this 33. Okay, so that means 33 plus the other 33. Remember, there are two angle y's there. Okay, so our next equation will be, okay, this will be our equation to solve for x. So this will now be 2y plus dx must be equal to 180 there. But we already know our y. So this is 2 times 33 plus x is equal to 180 there. Okay, here's our working equation, and this continues like 2 times 33 is 66 plus the x is equal to 180. Okay, and so we're going to subtract 66 from both sides. So this will be minus 66 and minus 66 there. Okay, all right, and so we have here x, that will be 180 minus 66. Okay, and so that should be about 114. That becomes 7, and we have a 1, and then we have, that's another 1. So this will be 114 degrees there. Okay, all right, and so that should be the measure of the apex angle. All right, you can see the answer blinking on screen. All right, trying to make it blink. All right, so that should be 114 degrees. All right, that goes to our number 8. Let's continue with number 9. All right, here's number 9. Okay, here's our number 9. Find the value of x, and let's determine if it's an angle or a side. Okay, so this x looks like for an unknown angle. Okay, this. All right, from the figure, you don't really need to solve it. Okay, because from the marks in the triangle, this side is equal to this side. Now, this side is opposite to the 65. Okay, and then this side is opposite to the x. Okay, so if these two sides are equal, then the base angles are also equal. And so our x here is also 65. The answer is angle x is equal to 65 degrees. Yeah. Okay. All right. We can verify that. It must be 65. All right. 65 degrees. So in an isosceles triangle, if two sides are given equal, the two opposite angles to the two sides are also equal. Okay. The two angles opposite to the two sides. Okay. All right. And so we can conclude without any computation, the x is 65. Okay. Based on that particular statement. All right. So we can continue with number 10. Let's continue with number 10 here. All right. So we clear first. Clear the answer, because if we move to the next question, it shows the answers sometimes. All right. So I usually cleared this answer. So let's continue with number 10. All right, here. Find the value of x from the figure. Okay, so let's examine the triangle. We have two sides equal. Okay, we have two sides equal, and all right, this angle x is also equal to the angle here. So you can call this also x. Okay, like that. All right. Why? Because the marks of the sides. Okay. These two sides of the isosceles triangle are equal, and so the opposite angles. Okay, the opposite angles, which are called base angles, are also equal. So we can mark the other one x. Okay, and so we can actually have the equation. All right. How do we make use of the equation? All right. We have our working equation now. X plus x must be equal plus the 50, okay, plus the 50 degrees. X plus x and the 50 must be the total for any triangle, which is 180. So here's our working equation. And so we can simplify this and solve for x. We will have 2x, x plus x is 2x plus 50 must be equal to 180. Okay. Next statement is subtracting 50 from both sides. So we subtract 50, we subtract 50 there. And so the left side becomes 2x. The right side will just be 130. Okay. Yes. All right. And so next we shall apply division. So we shall have 2x. Okay. 2x divided by 2. And we have here, okay, that will be equals, this is going to be 130 also divided by 2, okay, like this. And we put the division symbol, okay, this is divide, also this is divide, there, okay. So 2x equals 130. If you divide the left side, you divide the right side. And we find the answer like 65. X is equal to 65 degrees. All right, x is equal to 65 degrees. That's the value of the unknown angle. All right, how shall we check? We can always check our answer. That means x plus the 50. All right, so we have 65 plus 65 plus the 50. All right, this must be equal to, this will be add, okay? And so what shall we get from 65 and 65 and 50? That'll be 10, carry 1, and we have 6 and 6 and 6. So that's 180, okay? So that will be a total of 180 degrees. So x is equal to 65 must be the right answer, but we can always verify from the computer there, okay? So it is 65 degrees. Okay, that goes to our number 10. Let's continue with the next number 11. Let me clear the screen. This is number 11. All right. Okay, here's the next diagram. Not all diagrams are simple. So we have here an angle outside of the triangle. Okay, so we're going to solve this in sequence. So step by step. There's no direct formula. All right, so first this is 120. Okay, there, that's 120. Now this is straight, okay, like that. That's a straight. All right, let me clear that. This is supposed to be straight. There, okay, it's a straight there. All right, and so the other angle inside must be supplement 120. Okay, what is supplement of 120? It should be 60, meaning the sum of the two angles forms a line. Okay, so the angle inside must be 60 there. Okay, so this angle inside must be 60. Okay, just 180 minus 120, that's a 60. Now, observe the marks of the triangle. This one is a mark, also this, and also this. That means all the sides of the triangle are equal, okay? And that means equiangular. And equiangulars are equilaterals, okay? So that means all the sides are equal, all the angles are equal. And so you can say that, and you can conclude, this is also 60. There, that is also 60. This angle here, okay? That is also 60. And so the remaining angle x is also 60, okay? So this must be 60, and we have the answer. Angle x is equal to 60 degrees. There, okay? Angle x is equal to 60 degrees, okay? All right, so we did it step by step, and the answer is there, okay? All right. So that should be 60 degrees. That's the answer. All right. Next, number 12. Let's clear our writings first. And the answer, of course, okay, because if we move to the next number, the computer shows the answer too. All right, and so let's proceed to number 12. All right, here's number 12 figure. Find the x. So we identify if x is side or angle. And it looks like that must be an angle, okay? We're looking for this angle there, okay? What is this angle? Okay, now what do we have as a triangle? You can observe the red marks, okay? The red marks for the sides. And that means the three sides are congruent, meaning all the measurement of the sides are equal, okay? When the sides are equal, the angles are equal, okay? The angles are equal. And so we can conclude this is also 60. That's 60 degrees. This is also 60 degrees. There, okay? All right, and so we can mark this angle 60. This is also 60. There. Now, this particular side of the triangle, okay, this particular side, okay, forms, okay, two angles that are supplementary, dx and one of the 60-degree angle. So that means if this is a straight line, then x plus 60 is 180. You can now write a working equation, okay? You can write x plus 60 must be equal to 180, okay? This is our working equation. And so you can solve for x. So we will start by subtracting 60 from both sides. There. And we shall get the left side x and the right side 180 minus 60. There. And so we have the answer. All right, 120. That's the value of x, okay? It's an exterior angle, okay? It's outside the triangle, so that's the unknown. All right, and so what is the answer? There, okay? All right, the computer shows the answer. It's 120 degrees. Okay, all right, so we'll continue with next number 13. Let's continue with the next number. Here's the next diagram. All right, try to analyze first the diagram, and it's not really that simple. Okay, so you're going to see the given, okay? You have one side here equal to this side, and that also equal to this side here, there, okay? So we have three segments here that are equal in measurement. Okay, so how do you step by step solve this? Okay, you're going to begin with the 69 degrees, okay? And try to figure out what part of this diagram can be equal to that 69. Okay, you can see this side here and this side here of this triangle. Okay, that means there's an isosceles triangle here. Okay, an isosceles triangle is a triangle with two sides congruent. Okay, if these two sides equal, then these two base angles are 69. Okay, so we can actually type in there 69 there. Okay, so that means this is the given. You can conclude this is also 69. Okay, all right. We shall call the third angle over here. Let's put a mark here. Say this angle is, let's just put a variable here called y. Okay, say for example this is angle y there. So from this triangle you have one equation. Okay, we can call it our first equation, 69 plus 69, okay, plus the angle y, that should be equal to 180. Okay, the measure of all interior angles of any triangle is always 180. So if we add 69 and the 69, which we concluded from the statement, if two sides of a triangle are equal, then the two angles opposite the sides are equal also. So we have 69 plus 69, and the third angle y, that should be 180. Okay, so we can definitely solve for y. Okay, so this will be like that's 69 and 69, that's 138. So we can continue with 138 plus y is equal to 180. Okay, next step is 138 subtracted from both sides. Okay, so we're going to subtract here minus 138 and a minus there, like that. Okay, so left side will just give us the variable y. The right side will give us 42. Okay, so this must be 42 degrees, like that. Okay, all right, so which one is 42? The angle marked y. All right, what's our next equation? You can see a mark here, which is a mark for right angles. Okay, you can see this mark here. All right, this mark is for right angle, and right angle measures 90. Okay, so our next equation will be, okay, next equation will be, we have x plus the y must be equal to 90. There, that's our working equation. But we already know our y, that's 42. Okay, so we can do substitution. X plus 42 must be equal to 90. Okay, this is angle addition postulate. Okay, this is angle y plus angle x equals the right angle. Okay, so we have x plus y equals 90. All right, but we know angle y is 42, so we continue by subtracting 42. This is minus 42. This is also minus 42, like that. Okay, and so x is computed. This will now be x, that's equal to 90 minus 42, and that gives us 48. Okay, this will be 48 degrees. Okay, that goes to our x. This is our answer. That should be 48 degrees. All right. And we shall verify the answer. 48? Yes, so it's 48, all right. So it's 48 degrees. Over here below the diagram, you can check and verify. All right, next, number 14. Let's continue with the number 14. Here's number 14. Let us shrink it a little bit. Some parts are not displayed. Okay, all right, there. Okay, find the value of x. All right, you have to see you have to see your plan how to approach the problem, okay? So the given is right here. This is 56. This particular angle here, part of this triangle, okay? Part of this triangle, you have 56 degrees, okay? There must be some simple solution, okay? All right. You can see this particular segment with a mark. And this particular segment has a mark also. That means this side is equal to this side, okay? And we can conclude this is also 56. This part here. This must be 56 degrees there, okay? Now, that 56 degrees is part of the right angle, okay? You can see the mark. That means x and 56 are complementary, okay? The sum of x and 56 is 90, okay? Because of the mark, okay? The mark here, the corner, all right? That means right angle, okay? And so we can make use of x and 56 as complementary angles. So our working equation for our solution, that must be x added to 56 must be equal to 90. Here's our working equation. And we can have a simple solution, okay, without considering the other parts of the diagram, okay, like that. All right, and so we can just solve for x here. So by subtracting 56, subtracting 56 there, subtracting from both sides, that should be about x is equal to how much is that? That will be 34, okay? 34 degrees, okay, 34 is the answer. There, okay, you can see the confirmation at the bottom of the diagram, all right, the blinking red number, okay, all right, that's it, and that's the answer for the x, okay, all right. Next is number 15. Let's continue with number 15. At least you should be able to see how you can solve in sequential, okay, from the given up to the x, okay, considering the definitions of isosceles triangle. Next, we have number 15. Consider this diagram, okay, consider this diagram, and we shall consider some assumption, okay. This side here equal to this side, okay. All right, and this side here and this side marked with two okay, two ticks, all right, and that means these two sides are equal, and this is a straight line, okay, a straight line here like that, also another straight here, okay, another straight, okay, another straight. Okay, what do you conclude? All right, we have angles here. Okay, we can mark this angle, okay, mark this angle equal to the other angle there. Vertical angles, okay, there, vertical angles. So definition of vertical angles, okay, these are non-adjacent angles formed by two intersecting lines, okay. All right, and so these are equal in measure. All right, so how do you step by step solve this? All right, you can see these marks here and these marks. That means you can also mark this angle. We will use just, okay, we have used here two arcs. We can use here just, All right, just a letter. Okay, so let's make use of letters. Let's mark this y. Okay, if that is angle y, this is also angle y there. Okay, because of these two marks, then we have an isosceles triangle over here. Okay, and this angle y and this angle y are the base angles opposite to those two sides. So that means this angle y equal to this angle y, because these two sides are equal. Remember, if two sides of a triangle are equal, the two angles opposite to them are equal. Now, you can see another vertical angle here. This is straight, and of course, this is straight. Okay, so that means this angle y here is equal to this angle. Okay, by definition of vertical angles. And so we can conclude that angle y, okay, angle y is equal to 69. Angle y is equal to 69 degrees. Okay, all right. And so we can call this angle here in the other side. Okay, look at the other side. This is x. Okay, and these two markings means this is also x. Okay, there. Because of these marks here in the other figure, okay, these marks are two equal segments, okay, and this we can conclude this x is also this x, okay, because this is another isosceles, okay, a triangle with two sides equal. And so the x here and the x here are equal. And so if you have vertical angle here, okay, this is also x, okay, there. Okay, and so we now have our solution. We have something like x plus y, okay, is equal to 180 there. But we know already the y, okay? This means we have x plus 69 is equal to 180 there, okay? And this looks like 138 plus x must be equal to 180, okay? There. 69 plus 69 is 138. All right, subtracting 138 from both sides, we're going to have minus 138 minus 138, okay? And we're going to have the x value. X is equal to 180 minus 138. So that should be about 42. There. All right, and that should be our solution and answer, okay? Solution and answer over here. There. And what's the answer from the computer? There. Okay, it's 42 degrees. All right, 42 degrees. Over here, you can see it over here. There. Okay, all right. That goes to our number 15 problem. Okay, let's consider number 16. All right, let's continue with number 16. All right, here's number 16 diagram. All right, try to analyze your drawing and see how you can solve it. All right, starting from the given, of course. All right, so we have the marks first. Consider the markings. You can consider the markings here. All right, you see this mark and you see this mark. Okay, that means we have an isosceles triangle over here. Okay, isosceles triangle, and these are two equal sides, and so we have here two equal angles at the bottom called base angles, and so this must be also 66 there. Okay, all right, And so we put here the 66, okay, because you have this other base angle 66. All right, and so we can solve this angle over here. Okay, let's call it angle y. Okay, let's put a variable here. Let's call this angle y there. Okay, and let's call the other angle inside. Let's call that angle z there. Okay, angle z. All right. So which one is angle y and which one is angle z? This is angle y there. Now this portion is angle z there. Okay. All right. Notice this mark here. This mark is over here. That means this triangle over here, adjacent to the first triangle, okay, is another isosceles. And so we can have another conclusion. This will have to be measuring also z, okay? All right. Remember, y, z are numbers, okay? Those are measurement of angles in degrees. So this variable we assign z is also this value here, okay? Why? Because you have a mark here and a mark here. So that means these two sides of this triangle equal. And so opposite these sides are the angles that are base angles of this isosceles triangle, also equal, okay? And so we will solve for y first, okay? After which we can solve for z. And once we find out z, okay, we will use z and the x. They are linear pair, okay? They are linear pair because this one is straight there, okay? This is straight. And so x plus z must be a linear pair. And they are supplementary, okay? Meaning the sum is 180, okay? All right, so we can make use of that particular definition, okay? All right, so we're going to solve this in sequence. We will get y and then z and then x. All right, so let us start. Our first working equation will be from the first triangle, we have 66 plus 66 plus the y must be equal to 180 there. So next line is 66 plus 66. That would be 132. Okay, so we have 132 plus y must be equal to 180. Okay, so next step is subtracting the 132 from both sides like this, and we shall get the y. Y is equal to how much is that? That becomes 48 there. That's 48 degrees, and we already know our angle y. We're after the x, okay? Not the other letters, we're after the x here. All right, so that should be 48 degrees. Our next equation is using this corner mark, okay? That means 90, all right? You know that mark, okay? This red mark here, this red mark here, there. I'll add some more red, okay? All right, this red mark here, that means 90. All right, so our working equation will be z plus y must be equal to 90 degrees there. But we already know our y. So by substitution, we have z plus 48, which is our y value, must be equal to 90 there. And so we have a known, one unknown, which is the z here. So this will be by way of subtracting 48 from both sides there. And z is obtained. Z is equal to 90 minus 48, and that should be about 42 there, okay? All right. Now we have our z. Our final equation will be the linear pair x plus z. Okay. So here's the last equation. X, solving for x now. We now have x plus z must be equal to 180. There. But we already know our z. Our z is 42. So the next line will be x plus 42 must be equal 180. There. Okay. All right. So we'll continue with, let's continue over here. Let's continue over here. Okay. We have our x plus 42 must be equal to 180. Okay. Then we subtract 42 from both sides, minus 42 and minus 42. Okay. X is obtained. X is equal to, how much is that? 138. There. Okay. Yes. Okay. 10 minus 2, 8, 7 minus 4, 3, 1 minus 0. So that's 138 degrees. That's the known required value, okay? X is equal to 138. We can verify that. Okay, you can check on below the diagram, okay? There, it's 138. Okay, all right, there's the answer. It's indicated by the computer. That's 138 over here. There. All right, that goes to our number 16. Let's continue with 17. All right, let me clear the screen, clear the answer, and 17. Okay, here's the next diagram. Okay, examine the diagram. It's a combination of several sides forming several triangles. Okay, notice the sides that are equal. So we will have to consider some parts so we can think of how we can solve for the x. Okay, all right. Consider this particular ray here. Okay, all right. This is straight. Okay, this is straight. And so we have a linear pair there. That's straight, okay? That's a straight like that, okay? All right. And so if that one is straight, we have another linear pair, which shows us that this angle plus plus this angle, okay? That should be linear pair, and they are supplementary. We can mark this using some letter variable. Let's call it just y, okay? So that we have our first equation, y plus 124, okay? We have y plus 124 must be equal to 180 there. We can use this working equation, and then, all right, what else can we do? You can check on this mark here. This mark and this mark shows this triangle is isosceles. Okay, and therefore the other angle here, that should also be y. Okay, y degrees. Okay, the measure of this is also y degrees. Okay, all right. So why? Because this mark here and this mark, opposite to these two sides equal, are two base angles that are equal. Okay, so this will be in a measurement equal to the measure here. Okay, all right. Now, once we obtain this, we shall use this mark here. This mark over here, okay, means 90 Therefore, we can solve for the other angle, all right, over here. And we can call that angle, say, let's use the variable z again, okay, z, okay. So that means the sum of the angle which measures y added to the measure z must be 90, okay. And so we'll be able to get a number for that particular angle. And what else can we use here? This mark, you can see, this mark is also over here. So we have another two sides equal in the other triangle. And so we can also mark the other angle over here. We can mark this also z. Okay, the measure of this is also z there. All right, and so once we have angle y, we get angle z. And when we know our z, we will get the x. Okay, all right. So we will have to solve this in sequence. Angle x here is actually an apex angle. Okay, an apex angle. Now, all right, let us begin solving this. All right, let's start with the unknown angle y. All right, so I have the equation here. We shall subtract 124 from both sides. So this is minus 124 minus 124. All right. So we get the y here. This is now y equal to 180 minus 124. That looks like 56 degrees. There. All right. After obtaining y, we can use the right angle symbol here. Okay. All right. And so we have our next equation. Okay. Our next equation will be y plus z must be equal to 90 degrees. Okay. Like that. And we will now use the 56. We can now use this. We already know it. There. This is 56. And so our y here, we substitute the 56 and then the z, that's equal to 90. All right, we will now solve for the z. So this is by way of subtracting 56 from both sides. We get the value of z. This is equal to, how much is that? That will be 34. 34 degrees. Okay. All right, and so we have our z. We're able to solve for z here. It's 34 degrees. Okay, we can now make use of the other triangle. Okay, solving for x now. So this will now be solving for x. We have z plus z plus x must be equal to 180. Okay, now we make use of the value of z. That means 34 plus 34 plus x is equal to 180 there. So we will have here 34 added to 34, that's 68 plus x is equal to 180. Then we subtract 68 from both sides. This will now be subtracting 68 and subtracting 68. Okay, we will get, okay, we shall continue over here. Let's use the side over here. The right side of the screen. This will now be x is equal to 180 minus 68. That should be about 112, okay, degrees. There. That becomes 7, and then minus 6, that's 1. Okay, that should be 112 degrees. There. All right. Okay. And that's it. Y and Y, that's 12 and 11. All right. Is there another method of solving this? Well, if you remember the exterior angle theorem, you can conclude that the exterior angle in one corner or one vertex of a triangle is equal to the two remote interior angles. Okay, that's another way. You will notice if you're going to check on this figure, this angle y added to this angle y are the two remote interior, and the angle x here is exterior angle to this triangle. So y plus y is x. Okay, y plus y is x, and you can verify that. Okay, that's another way of solving it. 56, and then add another 56. Okay, that is equal to 112. Okay, that is equal to 112. This is the check there. You can use this for checking. Okay, if you're going to add, okay, 56 plus 56 is 112. Okay, that's the relation of x to the two y angles there. Exterior angle theorem. Okay, the exterior angle in a triangle is equal to the measure of the two remote interior. Okay, the two remote interior. So if we're going to investigate that, I can redraw it in a simpler manner. Okay, consider this triangle. All right, let me draw it for you over here. All right, consider this figure. Okay, here is the exterior x, and there are two remote interior y that are equal there. Okay, if you can still remember the exterior angle theorem, okay, this exterior angle is equal to the two remote interior there. Okay, there. So you have x is equal to y plus y. All right, so that's another way of solving it. All right, so that goes to our number 17. We shall continue with number 18. There's the verification there. All right, there. Forgot to show you. All right, that's 112. Yes, that's our answer. Okay, that's our answer. All right. Okay, let's continue with the last problem. This is the last problem, I think. Yes, it's the last one. All right, let's finish it. All right. Okay, so this is the diagram, and we shall be able to solve this in a simpler manner. Okay. The way to do this will be using the right angle. Okay, you can see the mark here. There. I'll add some red color. Okay, there. Okay, that means right angle. Now we have a given angle over here. Okay, while this particular side here forms a straight ray. Okay, this particular side here forms a straight. Okay, it's a straight there. So that makes the other angle inside here supplementary with 132. Okay, supplementary. So the sum of 132 plus this particular angle we can call y there. y plus 132 means 180. Okay, here's our working equation. Y plus 132 equal to 180. Okay, they form a linear pair because this is straight. And so you'll be able to solve for the y, and the other angle inside we can call with another letter. Okay, so we can call that, say, z there. And notice the z and the y, they are complementary. Okay, complementary. So we can write that angles y and z are complementary angles. There. Meaning the sum of y and z is 90. Okay. All right. And so we can have that particular equation later. Okay. All right. So for a while, we can move this over here. All right. So we can make use of the first equation. All right. Y plus 132 equals 180. We can solve immediately. We can solve for y. So by subtracting 132 there. Okay, subtract 132 from both sides. We get y is equal to, all right, how much is that? That becomes 48 degrees. There, okay? That becomes, yes, 48 degrees. All right. Next equation is z plus y, okay? The next equation is z plus y must be 90, okay? But we already know the y, so we can solve for z. Z plus 48 must be equal to 90. Okay, subtracting 48, we get the next equation. This will now be z, and this gives us 42 degrees there. All right, that should be the z. Okay. All right. Okay. Now, what is the relation of z to x? Okay, we can consider the next figure over here. Consider this next figure. Okay, if you consider this other triangle, you can see this side and this side. Okay, you can see this side over here, this side and this side. Okay, they are equal. Okay, they are equal. Okay, so knowing those two sides equal, then x and z are base angles. Okay, they are also equal, and so this angle is also angle z. And so we already have the value of x. X is equal to z, which is equal to 42 degrees. There. And so the answer for x is 42 degrees. Okay, that's the answer. X is 42 degrees. And we can verify that over here. You can see the mark, all right, there. You can see the red number at the bottom of the diagram. There. That's the answer for number 18, and this is the last problem. So I hope you were able to learn how to solve unknowns involving isosceles triangles. And we'll be solving some problems again using another topic in geometry. All right, so see you later.